Hello everyone, welcome back to our channel. Let's discuss the next fragmentation, that is in acid halides. Already we know that carboxylic acids RC double bond OH. In case of carboxylic acids we have seen that M minus OH, M minus COOH and COOH plus. Three peaks we have seen. So in the carboxylic acids we are replacing what? Some halogen. That's why what happens? M minus X, M minus COX, COX plus. If the carboxylic acid having the gamma proton, then we will observe McLafferty. See this one, in the first case what we are doing? We are doing the alpha homolysis. X radical is going to be removed. So this is M minus X peak. Okay. Next one we are doing alpha heterolysis. Thereby we are coming with R plus. This peak will appear at this particular M by Z. The second type of beta homolysis, that is at the CR bond. Thereby you will come up with this ion. The molecule is having the gamma CH function. Thereby we are observing McLafferty rearrangement. Next, the fragmentations in cyano compounds. In case of cyano compounds, we are observing M minus 1 peak, M minus Cn, cyclization followed by McLafferty. See the first one. Here we are doing with respect to the Cn, this is alpha bond and this one is beta bond. Simply removal of the hydrogen radical means what? Weight 1 or not. That's why this peak will become what? M minus 1 peak. So the homolytic cleavage giving the C radical and H radical. This C radical involving in the conjugation with these pi electrons. See this one. These pi electrons are involving in the homolytic cleavage. Thereby you are getting positive. We are getting the pi bond. Here we are getting the radical. These two radicals can form a lone pair and N plus. This is the M minus 1 peak. Here we are doing what? Alpha heterolysis phenomena. Thereby what is happening? R plus ion is observing and C triple bond N is going to be removed. Okay. The next one is McLafferty rearrangement. If the nitriles are having the gamma CH function, we will observe what? McLafferty rearrangement. This is one of the important thing, that is a cyclization phenomenon. In case of the nitriles, we are observing the cyclization, but we should have long chain. We should have long carbon chain. See this one. 1, 2, 3, 4, 5, 6, 7 and 8. If we have this much of the length of carbon chain, what will happen? Here the removal of olefin takes place. Initially what is happening? C triple bond N plus radical, it is the molecular ion. Okay. Later what happens? Here hydrogen radical is removed. Hydrogen radical removed means we are having a radical or not. This hydrogen radical approaches to what? The nitrogen. Okay. Thereby what is happening? This bond is subjected to homolytic cleavage. This homolytic cleavage is producing what? Two radicals or not. So these two radicals can form a pi bond. Thereby R CH double bond CH2 removed. Then we are going to have what? This kind of ion. This hydrogen is transferred to nitrogen. So we are having NH plus. The double bond is triple bond is converted into double bond. Thereby what is happening here? We are getting a radical. This radical and this radical can form a single bond. So in this way we are getting the ion. This ion will appear in the mass spectra. In case of these nitriles, what we are observing? Molecule and molecular ion interactions. Because of the molecule and molecular ion interactions, we are getting the additional peaks. How? See this one. This is the molecular ion. This is the molecule. In the molecule, what we are doing? Homolytic cleavage we are doing. Thereby CH radical and H radical we are getting. The H radical is approaches to what? The N radical. So RC triple bond NH plus. This peak will appear in the mass spectra. So this is the additional peak which we are observing in case of nitrides. The next type of compounds are what? Nitro compounds. In case of the nitro compounds, what we are observing? M minus NO, M minus NO2, NO2 plus peak and NO plus peak. The NO plus peak is commonly called as base peak, highest intensity peak in the mass spectra of nitro compounds. Let us see. We all know that the formation of the molecular ion in case of the nitro compounds are something different from the remaining compounds. In case of the nitro compounds, what we are observing, the electron impact or the electron bombardment is going to remove an electron from the minus charge. Thereby we are getting a radical. This is the molecular ion. Okay, this molecular ion is initially involving in the what? Alpha heterolysis. In the heterolysis, what happens? You will come up with R plus or not. So the R plus ion peak will appear in the mass spectra. We are giving minus charge to nitrogen, already plus is present. So minus and plus will be neutralized. Thereby NO2 radical will be removed. The next time we are doing what? Alpha homolysis. Alpha homolysis creating what? R radical. R radical will be removed and nitrogen is going to get radical. So this radical and the nitrogen radical both will form a pi bond. Thereby you will come up with NO2 plus. This ion will appear in the mass spectra. Here see this step. This is very important step. Here the rearrangement of nitro compounds takes place. See this one, what is happening? The O minus is approaches to the R. Thereby these single bonding electrons move towards the nitrogen. Already positive charge is present, we are giving the negative charge. So positive and negative both will be neutralized or not. So simply what is happening? The R approaches to oxygen. See this one? R approaches to oxygen. So OR and N double bond O. So nitro compounds are converted into what? Alkyl nitrides. Alkyl nitrides. Now this one is subjected to electron bombardment. Thereby what happens? Alkyl nitrides can form a molecular ion. This molecular ion is involving in the two types of cleavage. The first one is the what? This is alpha heterolysis. This is alpha heterolysis. This one is what? Alpha homolysis. Two cleavages we are observing. The alpha heterolysis produces RO plus ion. This will appear in the mass spectra. The homolytic cleavage creates removal of OR radical. Thereby we are going to get N double bond O positive. So these two additional peaks are always observed in case of the nitro compounds. The nitro compounds are involving in the rearrangement into what? Alkyl nitrides. Okay, so this is the fragmentation procedure of nitro compounds. Let's see the next type of compounds. Those are commonly called as what? Aminocycloalkanes. Already we have seen the fragmentation process of cycloalkanes. If you have the amino substitution, what kind of additional peaks we will observe? We already know that the fragmentation process of cycloalkanes. The similar kind of situation here we are observing initially. Okay. Here in this case, additional kind of peak will be observed. How can we get that peak? See this one. So initially we are having NH2 means nitrogen having lone pair of electrons or not. So molecular ion is always formed at the lone pair. So this is the formation of molecular ion. Then what we are doing, the beta bond is subjected to homolytic cleavage. See this one, with respect to nitro group, with respect to amino group, this is the alpha bond, this one is the beta bond. This bond is subjected to what? Homolytic cleavage. The homolytic cleavage creates what? Two radicals or not? See this one? One radical is here and one radical is here. In this case, what is happening? The transfer of hydrogen radical takes place from this carbon to this carbon. This is CH2 radical or not? We are giving hydrogen, the CH2 will become CH3 or not? Thereby, this radical is connected with hydrogen, converted into CH3. Then here we are having a radical. These two radicals can form a pi bond, thereby NH2+. Here the Carbon-carbon bond is subjected to homolytic cleavage, thereby CH3, CH2. Radical will be removed. So we are coming up with what? Radical here. This radical and this radical can form a pi bond. So pi bond, and this is the one of the major peaks which we are going to observe in case of the amino cycloalkanes. Similarly, cycloalkanols. If the cycloalkane is containing OH group, similar kind of situation is going to happen here also. See this one? It is the heteroatom. This is also what? Heteroatom. Beta homolysis, the formation of radicals, transfer of hydrogen, similar kind of ion will be formed in the case of cycloalkanols also. It means that what? In case of cycloalkanes, if we have the amino substitution or the OH substitution, we will get some additional peaks. So these are the additional peaks. You need to remember. So this is all about what? The fragmentation process of acid halides, cyano compounds, nitro compounds, aminocyclones, followed by cycloalkanols.